Good day, I'm Dr. Ding. In this short video clip, we are going to run multiple regression. Now, what is multiple regression? It is used to analyze the relationship between a single dependent variable or criteria versus several independent variables, or we call it as predictor or the factors. And it will result in an equation in which you are going to predict your dependent variable y from several independent variables x1, x2, x3, and xn. Then your dependent and independent variables must be metric, interval, and ratio scale, for example, test scores. But in certain instances, if your independent variables are categorical, you can actually change it into dummy variables. For example, you can use a coding of 0 and 1. If you have gender, for example, it's a categorical variable, you can code it as 0 for male and 1 for female and vice versa. Then run your multiple regression. Let's run multiple regression. Go to File, Open, and choose 5A multiple regression dataset. This dataset is used to decide which variables are actually used to predict your post-test of your result. And this is the data view. Go to Analyze, Regression, Linear, and we are going to choose the post-test as the dependent variable. How can we predict post-tests of your students' academic performance? And what are the independent variables or the predictor or the factors that is going to decide which variable that is going to predict the post-test? So we are going to use the 6 dummy here. The 6 dummy here has actually gone through the data transformation, in which, like for example, gender, we use the code for male 0 and female 1. And then subsequently for others as well, we use 0 and 1 for the coding to represent each category for these variables. Choose all these 6 dummy variables, the date of born, your gender, different group, computer use, and the treatment that they have gone through. Go to statistic and choose coefficient R and ANOVA. Continue. Click under save and choose predicted values and residuals. Continue. Then we can run the multiple regression. Click OK. Now let's try to analyze this output. From this result, we can see that the adjusted R square is 0.11, which also means that 11% of the variation of your dependent variable is contributed by the 6 independent variables or predictors or factors from here. And this adjusted R square is actually adjusted from the R square 0.13 here, and it is adjusted for your 6 variables here. In other words, your 6 variables contribute 11% of the prediction of your population. And this result also shows that these 6 variables can significantly predict your post-test, which is your dependent variable, since the SIG is lesser than 0.05 and F is larger than 1.0. Other than that, what you can get from the multiple regression is actually a formula like this. Postgraduates post-test can be predicted based on these 6 variables. 24.07 is the constant that value you get it from here, followed by year born, which is 8.68, plus 0.43 gender, minus 1.73 times group, and it is minus because it is negative here, plus 5.89 computer ownership, and so on and so forth. However, because the adjusted R square is only 0.11, which also means that actually the R square here is at the weak or low effect size, since it is lesser than 0.3 or lesser than 0.5. If it is larger than 0.7, means it has a strong effect size. So although this result shows that there is a significance here, it is significant, but then the effect size is small. You can further adjust on the variables here to get a higher value of adjusted R-square. That's all for this video clip. Thank you for your attention.